Welcome back to part 3 of this series in basic control. So far we've talked about our ladder logic, our relay logic and ladder diagrams, okay, the rails and the rungs and our wiring numbers and our schemes there. We talked about motor starters and how they pull the contacts in to make the three-phase motor come in and out for us. Okay, we're doing that now with control circuits, okay? Completely separate from motor circuits, okay? And we have talked a little bit about how we do our numbering and our wiring as we go in and out of devices. We talked about input and output devices in our ladder logic as well, okay? How the input devices always go to the left and the output devices always go to the right. And so we've covered a lot of material so far. We're going to continue on and we're going to talk about control relays. Now the nice thing about doing control relays now is that they operate identically to motor starters. Okay, we put voltage on a coil, we create a magnetic field, it pulls an armature down, and that armature drags some contacts together with it so that we can complete a circuit to our output device. Okay, motor starter does the same thing except for it closes the contacts and provides our three-phase power to our three-phase motor. So as you can see, the control relay works just identical to the motor starter, but they cannot be used interchangeably. I want to make that point real clear. You don't use a control relay to start and stop a motor. I'm going to show you why in just a little while. I've got a couple of examples here. This is an ABB. This is a Schneider Electric. Schneider Electric used to be Square D, then it went Square D Schneider, and now that's straight up Schneider Electric. Control relays have the coil, your A1 and your A2 for your armature coil, and then it's got an armature right here and behind there. And it's got normally open and normally closed contacts. Now the control relay has usually 2 normally opens, 2 normally closed. Okay, you can get them configured in all kinds of ways. You can get 4 normally closed and no normally opens, or the other way around. There's a lot of different ways you can configure them. I like the Allen Bradley type because, as you'll see in the lab with the one that you're working with, you're going to see that you can change and flip cartridges over and you can have the best of both worlds. So I really like that style that they created. There's also the Ice Cube relay as well. It looks a little different, operates on the exact same principle. You got a coil, you got an armature, closes contacts, there you go. Okay, so the exact same thing. So what does a control relay sort of do for us? Well, it's used to control multiple devices with just the use of one control relay. Okay, and we do that with those multiple sets of contacts that are in the relay. Okay, like I said, it operates just like a motor starter, the same principle behind the magnetic field. Okay, and you can have normally open or normally closed contacts, or a combination thereof. So you can come configured in a lot of different ways. All right, you've used a control relay if you've got a car with an electric fuel pump. Okay, you've got a fuel pump relay, and it's just like a control relay. Instead of running the amperage, the high amperage through the conductor that goes through our ignition switch, which is very small wiring going into up your steering column to your switch, we don't want to run that heavy amperage through there. Okay, what we want to do is we want to pull a coil in on a relay, on our fuel pump relay. We want to pull a coil in. It's going to close those contacts, and we're going to allow the heavier current that's required of the fuel pump to pass through the contacts, okay, and not have to pass them through the ignition switch or any other devices like that. We just want to use the ignition switch to fire the relay coil, and when the coil energizes, it closes those contacts. And like I said, the current that's required, the heavier current that's required for the fuel pump to operate, is now handled by those contacts. Okay, so just to kind of give you a little relevance there as far as you see in control relays. Okay. So let's go to our schematic. A couple of things here. We've added an extra rung of logic right here. So now we've got 3 rungs of logic. All right, and we've got a control relay coil. Okay, looks just like a motor starter coil. All right, but we have the designator or the identifier as CR, as your control relay. Okay, and the identifier in the motor starter is M1 for a motor starter number, for a motor number M1. Okay, so let's go over what we've got so far. We've talked. This is kind of learning how to read schematics. We're coming out of our transformer with 120 volt power, and we're going through our normally closed, manually operated push button switch, and it's going to flow through there, and we're going to stop right there because we have not pressed the button. We also have a set of contacts that are off of this control relay, and I know that because the CR and the CR are lined up. These identify the contacts that are associated with this coil. This could be labeled CRA or CR1, okay? So if these are the contacts off of that, our identifier has to match the one on the coil. So if we had a CRA, for example, suppose we had like four control relays, CRA, CRB, CRC, and CRD. Well, we want to be able to identify which contacts go with which control relay. So we call this, let's say we call it CRA. Well, we would want the contacts off right here to say CRA as well, so that we know that the identifiers match and that these contacts are the ones that are controlled by this, the control relay. So I want to stop real quick and show you, I meant to show you this earlier, but I've got a Allen Bradley control relay here, okay? And I'm going to kind of get up a little bit close if I can. You've got a couple of coils, a couple of terminals, and this is your coil, and this is your armature that's going to go in and out whenever we energize the coil. And you got your contacts in here that you really can't see. You're going to see them when you take it apart, but I just want to kind of show you a real life example there. So anyway, we've got our power going along here, and we haven't done anything, so we've got our power parking right here at our normally open contacts for this control relay. They're going to stay open until we energize this coil. Now, we also have power going to the normally closed set of contacts that are also on board with this control relay. And without energizing it, we're going to allow that voltage to pass through freely. We went over this with motor starters, and so you should know how the contacts work at this point. So without doing anything, just sitting here hands off, we should have a red light. Okay, we can even use that red light to say, hey, our motor's not running or our motor starter's not pulled in, okay? So let's go ahead and push the button. And when we do that, we energize the control relay coil. The voltage passes through our normally open switch. I'm pushing this down at this point. And we've got a control relay energizing, all right? When that happens, these set of contacts that were once closed, once open, are now closed. So the voltage is going to pass through, and we're going to energize the coil of a motor starter. Well, what happens? You should know what happens after that. We energize the coil of that motor starter. It's going to pull in these contacts right here. Okay? So now, when we push the buttons to turn on the control relay, we're also getting the motor starter to come on, and our three-phase motor starts to run. Okay? Notice also that the normally closed contacts that were here have now opened. They flip-flopped as a result of us energizing the coil. These flip-flopped, and so did these. So now the normally closed contacts are open. Our voltage stops right there. We lose our red light, which is kind of cool because we want the red light to go away as long as our motor is running, okay, as our motor starter is pulled in. So then when we let go of the switch, everything goes back to the normal state. We de-energize that coil. These contacts flip-flop one more time, and they now open, and these close back to where they were. We've got a red light saying, hey, motor starter's not energized, and the motor's not running either, okay? So that's how our control relay works. All right, and again, I want to pay attention here with our ladder logic, kind of go back to that for just a second, in our schematics. Okay, we've added a third rung, all right? So we also have to identify that with our rung number. So we've got 3 rungs of logic now. Notice also we've gone 1, 3, 4. 2 is always reserved for our neutral. Okay, so this is 1 also because this is 1 circuit right here, not just 1 wire, but 1 circuit, okay, coming up to here. So up here on the top side of the contacts, here, we're going to have a wire stuck in there with the number 5 wrapped around the insulation, okay, as our part of our numbering system. Excuse me, we're going to have a number 1, my bad. So we're going to have a number 1. Then on the bottom side of that same set of contacts that are going to go out, in this case, and fire our motor starter coil, it will be labeled number 5. So you'll have a 1 going in here and a 5 coming out as far as our numbering system goes, okay? So, and then we've added another set of input devices here, and this one being the normally closed contacts on the control relay. So we go in as 1, and we come out as a number 6. So in other words, the normally open set of contacts will have a 1 going into it, coming out as a 5. We'll also have a number 1, okay, going into the normally closed set of contacts and coming out as a number 6. And it's going to be hooked up to a red light, excuse me. So that's how our numbering scheme works. Remember, these are all tied together, so all of these are number 2 because they're all neutrals. These come after the load, okay? After we've depleted our voltage here, and we're going back to home, where we always try to get out when we leave the transformer, okay? So that's how our control relay works. We can use another set of those normally open contacts. Remember I said they had, some of them have 2 normally open, 2 normally closed. Well, we're going to use a second set. Here's the first one. We're going to use that second set as our seal-in circuit around our momentary manually operated push button switch, okay? So it works just like the motor starter auxiliary contacts did, okay, in our motor starter circuit from the previous lesson. So let's watch this one here. We got the power coming up here to our switch. We're connected right here, and we have a voltage sitting on a set of contacts right there. Okay. Now, the moment we push our push button, we energize that coil. This normally open set of contacts is closed, just like this other set is normally open. It's now closed. Okay. So, but focusing right here, what I've got is 2 parallel paths of power supplying voltage to the control relay coil, okay? So I've got a path here energizing the coil, we're tied to here, and this is a second path that's energizing the coil. When we let go of our push button, we don't have voltage coming out of the switch anymore. That voltage is still there though because we have that second path established, okay? Now we're running our control relay, and we're continuing to keep our contacts closed on the second run. Okay, back up for just a second. When we push this, we seal in. We've also closed the set of contacts. Our motor's running again, and we've dropped our red light saying the motor is not running. That's our little warning light. So that's what's happening. I let the button go, and I still have control relay voltage coming to the coil. These contacts stay closed. These contacts stay closed. So I'm going to keep my motor running. So as a result, I push the button, seal that in, get my motor started to run, I let go, my control relay is still operating, as is my motor starter, okay? And we still have our light turned off saying that it's not running because it is running, okay? So we let the button go, we have to hit the E-stop, it breaks the power, and once it breaks the power, we let it go, the voltage will come back to here and just sit here and wait for us to initiate the power again, so hit that cycle again. So that is how a control relay works. That's what it's used for. One other application I just got to thinking about is in your HVAC system, your thermostat. Sometimes you'll hear, if you've got particularly if you've got a digital and an analog, not so much, but you'll hear sometimes if you're dialing up the heat in winter or something, or dialing the air conditioner in the summertime, you'll hear a relay click behind there, and that's what's going on, is you're bringing a relay that's handling, that's got a small voltage to bring the coil in, to bring the power out to the larger components like your compressor and your blower motors and things like that. So you've got a control relay in there behind that thermostat as well. You can often hear it click. That's what that clicking is. Okay. The other thing I want to talk to you about in this particular segment is cross-reference numbers. All right. This is going back to the schematics that we've been working with. Okay. What this does, what cross-reference numbers do for us, is that it allows us to find the normally open and normally closed contacts of a control relay. Now, one of the things that you might run into when you get out in the field is you might find a set of drawings for a machine, an entire system, maybe 100, 200 pages long, okay? And it could have 40, 50, 60 control relays in that system. And if that's the case, you're not going to know where the normally open contacts are or the normally closed contacts that are associated with that particular relay, and you'd have to go through line by line, page by page. It would just be impossible to try to find those. Well, cross-reference numbers have given us the direction to go in when we're looking for those particular contacts based on the output device. So let me show you. This directs the technician to the normally and open and normally closed contacts in the schematic. So it's a lot of times. Here's how it does it. I'm going to use just the number 3. Okay, I just pulled that number out of thin air. Okay, so you use a number, and when the number has no underscore or no underline to it, that indicates the rung number that we'll be able to find the normally open contacts for that control relay. All right, I'm going to go to a drawing and clarify that in just a minute. If we see a number, and by the way, this number here is on the right-hand side of the neutral rail, okay? It's on the opposite side of your rung numbers. It's way over here to the right, outside to the right of your neutral rail, okay? That's where you'll find that number with no underscore. Also, you may find a number with an underscore, okay? And it may be below or an overscore with a hash mark over the top of the number. It could be either way. I've seen it both ways. That number tells us where we can find, what rung number we can find the normally closed contacts for that particular control relay or motor starter. Okay, this applies to both relays and motor starters. Okay, okay. So here's what I'm trying to get at. So right here is our cross-reference numbers. Okay, so here you'll see a 2. I don't know how well you can see this, but this is just a 2 with no underscore at all. So the way I look at that cross-reference number, it tells me I can go to rung 2 and find a normally open set of contacts, and I look to the left, and I should see the CR designation. Okay. So if I'm looking at my schematic and I need to find out where the contacts are for this control relay. All right, so we know the control relay is pulling in, but the control relay contacts aren't doing their jobs. They're suspect. Okay, so we got to go find those. We got to find those contacts. So on my cross-reference numbers, I go over here. The number 2 has no underscore or overscore, so it tells me that on rung 2, I should find a normally open set of contacts labeled, and I shift to the left just a little bit, CR. So if I go to rung 2, normally open set of contacts labeled CR. This could be labeled XYZ, and then on rung 2 we would find a set of contacts XYZ. Doesn't matter. I'm just saying that the contacts associated with this control relay can be found on rung number 2. Okay. Likewise, if I have the number 3, and for those, just in case you can't see it, this is a number 3 with an underscore. Okay, it can have an underscore or an overscore. Okay, it tells me that on rung number 3, I should be able to find a normally closed set of contacts labeled, and I'm going to shift to the left, CR. Okay, so I go to rung number 3, and right there is a set of normally closed contacts. Normally closed because this is underscored. Normally closed contacts with the designation CR. There it is right there. Okay, and again, it could be labeled anything. The same thing applies for motor starters. Now, on this particular case right here, in this case, we don't have any, we're not using the auxiliary contacts off of the motor starter in our schematic, so I don't have any cross-reference numbers. If I were using, let's say instead of this control relay contact, I was using the auxiliaries off the motor starter, okay, I would have a number 3 with no underscore because the auxiliary contacts are normally open on a motor starter. So I would have the number 3 over here. I'd go to rung number 3, and I should find a normally open set of contacts with M1 as the label. Okay, so that's how our cross references work. And again, this is designed to help us instead of having to go through every rung of logic and every page by page. This set of contacts could be on rung number 450. Yeah, we're on rung number 1. Okay, but the contacts could be used on rung number 450 in the drawing. Well, I don't want to go through every drawing, and I know you don't either. And I don't want to have to scan every line. Where is the CR1 contacts? You just don't want to do that. So these cross references save us a lot of time and directly take us to the contacts based on the device on that rung. Okay. So that is cross-referencing, and that's also control relays, okay? That's what I got for you right now. We've got one more segment to cover, and that's troubleshooting. It's relatively short, okay? But that's what we've got so far. That's control relays, so be sure to watch the last video, and it's pertaining to troubleshooting, okay? Thank you very much.